Hi, my name is Brandon Craghead, and today I'm going to talk a little bit about some explosion VFX for games using Houdini's Side Effects Labs panel and the Unreal Game Engine. So let's go ahead and jump right in. Alright, so we're here inside Houdini 18, and we're going to be working with the Side Effects Labs panel, which will be located about up here once it's installed. This is also something important to note. They've renamed the Game Development Tools geometry node. And I like to use the torus for something like what we're going for. This kind of a mushroom cloud look. It just lends itself to a little bit better start there. Got a mountain node, a little bit create some turbulence on there. The create fuel will actually get our fire going here. Particle separation is something to take a look at. You can play this parameter and it just separates particles that actually spawn the fire. I throw a little noise in there, and file cache will kind of help keep things organized, keep some files saved out. And if we hop over here into the PyroSim, this is actually controlling our simulation. So in the Pyro here itself, the division size is something to take a look at. The smaller that division size is, the smaller, you can almost think about it like pixels. It's the smaller the pixels are going to be as far as how that renders it out. So smaller number is going to be better, better resolution, but a lot more render time. Right below it, we've got the size of our container here. So you can modify these. I just like to see about where it's going to go. If it looks like it's clipping, then go ahead and bring these out, but you want to keep this as close to the actual simulation as you can. The Pyro Solver itself is a lot here to work with. Timescale, you can just kind of slow down how the actual explosion, how fast it's working. You've got your temperature, cooling rate. Viscosity has to do with how it flows through the air around it. Buoyancy lift is how much vertical lift the actual explosion is going to be having. In our combustion, the ignition temperature is how hot that's going to be in originally. The burn rate is how fast it burns that off. This is how efficient the fuel is. Gas released is basically how much gas is released in that initial explosion there. With the shape itself, you can kind of play with these a little bit in here as well. The dissipation literally is just how fast it dissipates when it's finished. Disturbance, shredding is a good one. That kind of affects how sharp these little pieces or the licks of the fire is going to be. Something we can do that actually makes this kind of nice here too is you can actually visualize this turbulence. Go to the turbulence tab and turn this on. Take a look at how this is going to look. And this gives you an actual idea. You can kind of see it's going to kind of draw these little spaghetti lines in here and kind of show you how things are moving, and it's great to kind of be able to toggle that on and off. Disturbance, shredding is a good one. That kind of affects how sharp these little pieces or the licks of the fire is going to be. Something we can do that actually makes this kind of nice here too is you can actually visualize this turbulence. Go to the turbulence tab and turn this on. Take a look at how this is going to look. And this gives you an actual idea. You can kind of see it's going to kind of draw these little spaghetti lines in here and kind of show you how things are moving, and it's great to kind of be able to toggle that on and off. Alright, and some of these other tabs here. This dissipation, I wanted to make sure that I'm only using 64 frames in my particular flipbook here. I want an 8x8 grid, and the dissipation is basically literally just how it dissipates. So I wanted full, and then I kind of wanted to sharpen and cut off towards the end and just kind of dissipate, turn into nothing. Let's see, we can do, these were pretty basic. The shredding is another thing you can do. You can turn on this visualization. which is kind of nice. You can kind of see how the shredding towards the ends of the flames ends up going there. Turbulence we looked at. Confinement is also the... There we go. Confinement is where we're at in the container and the resistance of the air around it and the way the fire is pushing out on that. So that's a nice visualization as well. Just toggle these on and off as you kind of play with those a little bit. In color over here, this does not actually change the color per se of our explosion. That's going to be in the shader. But again, with this dissipation, I kind of wanted to play with this and see how it was dissipating and then kind of slowly taper off into nothing. And then we just hop back up. If you press U on your keyboard, then you can hop up in your levels. U for up. So we'll go into our Pyro import here. And basically this is a place you can save the file cache. And this is important, especially in Houdini. Caching is a really big deal. We need to make sure and cache your frames out, cache the geometry out, so that when you go to play it back, you can draw upon that for other options we'll talk about here in just a minute. But that's a lot of what keeps these simulations working well. And let's see, I do always set up a camera, and that way you can see what you're working with and where it's going to be in frame essentially. And as this comes out, once you've played with your different parameters, you definitely always need to kind of let it buffer, basically. Let it play out, watch, see what's happening. And the blue down here represents what's being cached. And it'll automatically do that with those cache nodes that are set up in there. Alright, I pause that there for just a moment to let it finish buffering. Sometimes towards the end it seems to take a little bit longer, but that's alright. Once this is cached out, however, you can kind of scrub through here and see what your simulation is doing. And let's see, we'll actually hop into our camera here. We'll throw this guy back down in the middle. And with the camera, so basically this is where you're going to move it in the X, Y, and Z. As far as placement goes, with rendering, especially doing a flipbook, you're going to want to actually have the orthographic view. You can do a view that's off, but it actually is harder for it to compute, especially if we get into motion vectors, which we're going to talk about also in just a moment here. You can set the resolution of your camera. That can be modified later, but it's nice to have a good base to start off of. Focal length, aperture, everything else you'd want to do in the camera here, just like any other 3D software. And that's kind of our basic setup here. Then we're going to hop over into our out node for rendering here. And I mentioned motion vectors. We'll jump into that here in just a moment. The mantra node is what I'm using here to render. And there's quite a few options in here. Once you get this buffered out, you can do a render to mplay and just kind of get almost like a preview render. That can take a few minutes to get, but that's also nice to have. You can set your render frame range, and again, I've just because I wanted the explosion to start, just at the base and then move up 64 frames, and we can change the resolution here. Like I mentioned, you can put a custom user specified. If you're doing testing or if you are doing render to mplay, you can cut that in half or into a quarter. It's sometimes nice to make that go a little faster when you're testing. Let's see, before we actually do a solid render, there's some things to take a look at. And one of those things is the motion vector I mentioned a couple times. Motion vectors are really impressive. What they do for your flipbook in the game engine is they interpolate the distance between each of the frames and makes that much smoother. And we'll look at an example here. But basically, if you slow the frame rate down, you do see the jitter as it moves from one frame to the next. And what the motion vector does is it actually sets up the math in between those, and it renders out an image, another flipbook that you attach, that the game engine can read and interpolate those frames together and make an extremely smooth transition. It works just about like magic, which is great. So you just drop this node in here. It's just motion vectors. So you would just come in and type motion vector labs, labs motion vector. Get that guy in here. You go ahead and want to make sure that you've got your frame rate where you or your frame length where you want to see to have that be. You do need to have these nodes set up, so you want to make sure you have the export node that it's looking at. So you want to make sure your pirate import we set up earlier is connected there. You'll hit accept, and then you want to make sure your camera is also looking through the camera that you've set up. You want to make sure that the where it's going to be rendering, the output picture here, where that's going to be set up. So basically it's just going to go here under render. And something else you can do in Houdini is if you click on the middle mouse wheel, it will actually show you on this actual title here a little bit easier version of this to read. Instead of anything that might have the script in here, you can read that in human terms, so that can be nice to help see where those things are going. And it's important to know where those are going because as we connect a few of the things, you're going to need to reference those. Anyhow, so we've got the Atlas resolution, and this is going to be the resolution of the total map. So with our 64 images, which is an 8x8, what I've set it up here to do is a 512 by 512, and that's a pretty high resolution, so it does take a minute for that to work. Let's see, and then basically what you'll do is you'll just you'll hit render, and this will render out an image for you. The other thing that we've got here is this texture sheets node, and this works really well for the game engine set. And there is another way to do this manually, and this is just doing it under the hood for us. But basically, it's basically creating a mosaic node and bringing that back out for us. And what's nice is it will actually communicate to your mantra node, so you can sync up your start and end and your resolution and everything else in there. So that's pretty handy. What you can do here is you can render out a few things. You can just do your render sequence. You've got your normals, and actually when you do drop this in here, it will actually, if we bring this back over to the OBJ, it'll bring in this guy, which I'll show you what this looks like here. We'll go. So you see these little lights down in here, this RGB lighting. It will automatically create that for you. When you drop this in and enable these, you need to have these checked for that to work. This will export your normals if you have this checked. This will use those render RGB lights and an emission layer as well, which are all pretty important. And then what you can do is you can actually just render out your color map, which is nice, or you can render out a packed map, which will actually combine all three of those into one map, which is nice for space saving if you've got your pipeline set up like that. And then with these, again, you want to make sure your numbers are consistent. This I was playing with earlier, so we'd want this to be that 512 instead of 1024, because that's quite large. So go ahead and adjust that before we go ahead and hit render. But the other thing I do want to take a look at is right up here in the mantra node. What you can do for a little bit more control is we can have different render layers. So in the images tab, again just under your mantra, images tab, and in the extra image planes, you can come down here and you can add extra image planes, just this plus here, and bring those up. And what I've got this reading from right now is actually in our material. If you go to exports it's actually got a smoke mask and a fire mask, and you can just copy and paste these and then go back into our out and paste those in there, and it will read those masks. And what's nice about that is if we go back to, say we do our render view, and we do actually, let's set up our camera here first. Okay, there we go. Back into render view, and as you hit render, once those are set up, okay, we give that just a minute to render, and once it does, when we click this drop down, this little arrow over here gives you a few more options, and what it shows by default is the color layer. But because we pointed it to these smoke masks, we created those extra layers in our monster node right in here. Right, we made this under image, extra image planes. We can preview those right here. So there's your smoke, there's your fire, and these are great for post-processing if you want to have you know, some more control there in how that that shows up, which is great. Any of these boxes, whatever you think, whatever else you might need, you do at least have to have one of these checked in order for this to render these out. And then you would go ahead and do render to disk, and the location right here is actually quite important. Again, you can click middle mouse, click that there, and look in human terms. Where we've got these going, you can kind of set up some file structures about where you want to put those. But where this ends up going is important, and then the your ending here determines your file type, right? Especially if you have this option to infer from file name. That's default in there. I did set these up for both just to be a little more foolproof. I was using a PNG, which worked out just fine. And once you render those out, it will actually render them both in the same pass, which is great. Go to our image network, and what I did here is we had just this file node to bring in those images, and right here is going to reference where those images came from. Now, something that's super helpful is this little checkbox right here. Okay, if not, it will show all of these frames individually, and that's quite the daunting list. If you check this box, it'll actually group them by your file name into the frame range there. So, you know, say hypothetically we've got the you know, maybe we want to do just the base color itself first, right? So we would go and navigate where I put that. So I've got color. You click on that here, and then you hit accept, and it will pull from there. And what I've done is I did one of those for color, the fire, the smoke, and then also for this is for my normals right in here. You drop that in, and you drop down to just a little mosaic node, and go to composite tab. Okay, if we just have the individual file flag checked, then we just see our very first frame. But then with the mosaic tile, the mosaic flag checked, it will show you all of these. So that's what this mosaic node will do, which is great. It'll make basically make your flipbook for you. And then what I have here is a little lookup node, and the point of this is to basically just do some color correction. So I've just got a color amp in here, and I've kind of just adjusted these parameters to sit where I want them to. And then down here I have this this mask, and what this is doing is it is taking this guy and masking out from this guy, right, and bring it down here to this pre-multiply, because it takes the image, let's find a good one here, all your little rendered images, and these are again quite large. This was 8192 out of the total, so we have to get really close to see any difference here. But what this little pre-multiply does for us is it takes, so you see your color here, and if you swap over to your alpha and watch this edge right here, it takes just a couple pixels out, so you don't get any halo around your rendered flipbook there. So you can go even closer here to see. So it's just a couple pixels in there, but it does make a pretty big difference. So that's a nice handy little node. So usually drop that in there on under my flipbooks, and then you have this ROP. This is your out node, and yeah, so that will actually render out all of my little flipbooks for me. And you know, what I've got here is like just these three set up. I can just kind of move them over to what they need them to be, and you know, now this will take and this will render out my smoke for me, and this one over here will render out my normal maps. And really any set of images that you have already rendered out that you can call in here and you can bring in and do the same thing. So it's a pretty good little system. Yep, you can see there's the normals. So once you have all of your flipbooks rendered out, go ahead and take that and open that up in Unreal or any other game engine and apply those flipbooks there. So we'll head over there, take a look at that. Alright, here we are inside Unreal Engine. As you can see, the flipbook is loaded and seems to be working fairly well. And a quick note, I've got this set up in the Unreal Abandoned Warehouse level to test some lighting and see how things look when it's pre-set up. Let's go ahead and jump in and take a look at how that works. So the first thing I should mention is this flipbook motion vectors node. It's a pretty handy little node actually, and one thing I actually should dump into really quick is this constant bias scale. If you click into this and open this up, there's a few things going on here, but this guy right here, in fact I made this note to myself actually, this constant bias scale. When I did some research, and when I first hopped into this, this was a positive 0.5, and this needs to be a negative 0.5. And what this does basically is it sets it back to being in a 1-to-1 space, or 0-to-1 space. That way, the way the motion vectors are calculated, it actually works much more fluidly. And that's pretty much the focus of this whole node, is working with this motion vector. And kind of bring this in just a little bit. I'll let you watch that for a minute. This first pin here is the timing itself, which you just got a time input and a little parameter, and what's great is that carries over and we can kind of manipulate that in the material instance. Multiply, fraction, and then pop that in there. We have the X and the Y columns. So for example, I have an 8x8 in my flipbook. If you did a 6x6 or a 10x10, whatever you brought in, you'd want to pop those numbers in. The texture 2D. When you bring your images in, you need to make sure and not be a texture sample. It needs to be a texture object, otherwise it'll give you some errors. Then we have the motion vector itself, which, in fact, we'll just open this up real fast. This is what it looks like when you bring it in. And when you actually import this into Unreal, you definitely need to make sure that it is set to linear, not sRGB. That is quite important, actually, to linear color. And then, let's see, moving right along. Let's see, so this motion vector raw multiplier, this is also quite important, actually. This little node, as it hooks into the pin, this is a multiplier that changes how the motion vector is read with a flipbook. And when we're based on timing here, that makes quite a big difference. I happen to know that when I exported out of Houdini, it was at 24 frames per second. And what I literally did was just 1 divided by 24 gives me this decimal equivalent. And if, well, this is thinking, just to show you what the differences might be, let's, I don't know, go point 0.6. And as this updates, you'll see what's happening here and why this parameter is so important. So while this updates, we're going to go just keep on running through. This double apply motion vector is basically, it's a little more expensive on the system, but it actually makes the animation much more smooth. So if you can afford that, it's absolutely worth it. What I also have here is I have a it's just a black and white version of the smoke of the flipbook, and then this is just the fire itself. And the reason I separated these is I wanted to have a little bit of control, a little more control in the emissive. And then also the normal that I exported out of Houdini. These all came out of Houdini. When I come over here, if you notice, I do have 3 motion vector nodes, and that is because you cannot pump in a multiply into the texture 2D. It will not accept it, gives you an error if it's already hooked up. So I have to do this after the fact. And where I wanted to have, the flipbook will work just fine with just one, but where I wanted to have this fire separately so I could modify the emissive and then also have the normal come through, I set up each of those to continue that interpolation of those frames as it comes through on that 24 frames per second. And as those come out, basically, like I said, this was just a black and white of the fire, and that is kicking out just this multiply. It's blending the two, and that's going into my base color for the fire, or for the smoke, excuse me. And then I've also got each coming out to passing through this fire emissive down here, multiply it, and then blend overlay, and that's going into my emissive there. Subsurface color, just make sure it renders as transparent as it should, because I am running an alpha composite pre-multiplied alpha, which this material blend mode is actually great if it was pre-multiplied, say in Houdini, with that black background on it. It just makes that a little cleaner. This raw multiplier, see, it's got a little bit of jitter, so say we even just do 0.3. This is surprisingly interesting how this comes through, and if this shows up originally this way after everything's hooked up, it is the raw multiplier that's the issue. So basically we just get this jitter, and this is clearly not going to work. This is the motion vector that's not being calculated correctly with basically the frames per second, and so having that set correctly is actually vastly important, because what the multiplier does, it basically tells it what frame rate to work at. Something else to note is actually how this looks without a motion vector. Why bother with a motion vector? Well, if we disconnect all of these, and we again wait for this to update, you can see just how jittery these frames are running at this this frame rate. This was at a time multiplier of 0.1, so an animation would most likely not play this slowly, but you can see that's quite the jump and skip between each frame. And what that is just the individual images in the flipbook running from one to the next, but they do have that much of a gap between them. And what the motion vector does for us is it literally interprets and interpolates that data in between the two frames and blends them together quite smoothly. And actually, if I were to update this this value for a time multiplier, this is what I have it running in the other window, 0.26. It's moving faster and it's a little bit better, but you can still see that halo as it goes from frame to frame. And from a distance, this might not be too distracting, or if you can somehow hide that with just maybe a real quick burst in the explosion. But if you need to show maybe a slower large explosion, that really is going to show up. So this This motion vector is actually really quite handy and can have a really, really nice result there. So I would highly recommend giving this a shot. And let's see, we'll actually go and take a look here and just kind of show you a little bit of this final result here. And again, that's quite smooth. I think that turned out fairly well. And if we bring this down, get this out of the way. Here's flipbook in-game. Alright, as you can see, that turns out pretty decently. Oh, there's actually one more thing I wanted to go over really quickly, and that's this fire multiply and this time multiplier. Like I said, we can kind of adjust our time here. This is our material instance. And it's nice, I think, to have this in here to be able to slow this down or speed this up as needed, because a larger explosion is going to appear to be moving much more slowly. So if we did just kind of, it's a little slow, maybe bring this down a little bit. You know, if it was some mushroom cloud off in the distance, it would be definitely appear to be moving much more slowly as it's much larger. And then this guy here is our fire emissive multiplier, and if I toggle this off, you can see that difference there, that it's, you know, just adds that different little punch in the fire. Just kind of brings that up a little bit. Well, that is it for this breakdown, so thank you so much for watching.